Today we're going to look at what we call binomial distributions. So let's talk about what we looked at last lesson first. And what we did there is we talked about these probability distributions that are uniform. You roll a die, there's 6 outcomes, 1, 2, 3, 4, 5, or 6, and they all have equal outcomes, 1/6 here. And we're able to show that in table form, and we're also able to graph that. Okay, so this is going to continue, but our story today is going to focus on binomial distributions. And the word bi actually means two. So here we're interested in two outcomes that can come out of a trial or an event, I guess. And these two outcomes are known as a binomial distribution. And there's always two things that come out of these: a success or a failure. So those are the two things we're looking to find and to work with in our word problems that deal with binomial distributions. I'm going to move right into an example here. So example 1. So you're all familiar with Smarties, and the makers of Smarties, they're pretty smart. They know that most people actually like red Smarties, and they've had a lot of campaigns over the years about, do you eat the red ones last? So these Smarties, they actually make sure, since they're so popular, there's 40% of them being produced in every box. So if you buy a small box of Smarties, it's got 10, so the ones you get at Halloween, what do you think the probability is that 6 of them are red? So 10 Smarties in a box, the probability that 6 of them are red, knowing that the probability of them being produced are 40%. Okay, red, 40% red. So what we have here is an example of a binomial distribution. This has two outcomes. It's either red or not red. Every time we take a Smartie out, grab from 10, 1, then 2, then 3, then 4. Each time you grab one, it's either going to be red or not red. Okay? So red is like the success, and not red is the failure. Every time you pick a Smartie out of the 10 Smarties in the box, it's either red or not red, a success or a failure. Okay, so because we're interested in 6 red of the 10, we want to look at the probability of x successes, and x here would be 6. So here comes the new formula we're going to use for binomial distributions. Okay, so the binomial distribution formula reads like this. There's a combination out of n trials, and 10 are a success, and then you have the probability of a success, and Q here is the probability of a failure. So here's how the whole list reads. P of x, that's the probability of x successes in n independent trials. NCX is a combination of x trials occurring from n total trials. And P and Q are the success probabilities and failure probabilities. Okay, let's actually apply this to the Smartie example so it makes a bit more sense. I always find it's good to see an example, use the formula, and then the formula has more meaning after. So we want to find the probability of 6 red Smarties. We know that usually it's 40% for red. We want 6 out of 10. Okay? So from example 1, the probability of a red was 40%, and that's our success. And we're calling Q the opposite of that, which you know that probability always adds to 1. So if the probability of a red's 40.4, or 40%, then 1 subtract 0.4 is going to give us the probability of not red, which is our failure. So it's 60%. Okay, so we've got our P and our Q. We're running 10 trials, so n is 10, and we want 6 of them to be red, so that's our x. It really comes together well. So we want the probability, given a binomial distribution, of 6 red Smarties. There's 10 in a box. We pick 6, and it's 40% chance, or 0.4, to have 6 red, and then 0.6 that 4 are not red. Okay, notice this 6 and 4 always add up to the 10 here, to the n. Alright, you work that math out, and you're going to find that this happens 11.15% of the time. So, in summary, there's going to be 6 red Smarties, our successes, from total 10. That means there were 10 independent trials. It's going to happen 11.15% of the time. Now, for this particular example, where you have 10 Smarties in a box, you want to know what the distribution probability using a binomial approach for 6, and we found that. We can also look at something that we talked about last lesson called expectation. What do we expect to occur? What does the math tell us? And expectation is actually a lot easier for binomial distribution. The expectation, okay, is actually just the number of trials. So we had 10, and it was the probability of success of that trial. So it summarizes as follows. The expectation here is for a binomial distribution, and it depends on the total number of trials, which we call n, and the probability of success of an individual binomial trial. So go back to our Smartie example, and it reads as follows. The expectation is n times p. We had 10 Smarties in a box, and the success of actually finding a red one we knew was 40%, so 0.4, and 10 times 0.4 is 4. So we can say that the expected number of red Smarties we would actually find, okay, would be 4. That's why when we found 6 of them, it was quite low. It was only about 11.15% chance. Okay, so we'll have more to say on this in class. This is just merely a quick introduction here to the binomial distribution. So you should be prepared to take this further in class and to get some practice questions going. We'll see you in class. Thanks.